the heart. So which direction are we facing? Anterior or posterior? Right, this is the anterior side of the heart because we have this structure right here, the anterior interventricular sulcus. We also know this is the anterior portion of the heart because we have the, what is the structure here? The pulmonary trunk, which is always anterior to the aorta right here. Okay, we have our 4 chambers of the heart, these big muscular chambers, the pumping chambers. These are our ventricles. We have the right ventricle and the left ventricle, as well as the right atrium and the left atrium. Okay, the structures off of the right atria, they're still part of the atria, but these flaps are known as the auricles. Okay, can I follow off of your dissection guide? Okay, also along the anterior interventricular sulcus, you have what? What are these little branch-like extensions? Right, coronary blood vessels that are going to supply oxygenated blood to the heart, if they're arteries. Okay, so we already found the aorta and the pulmonary trunk. Keep in mind that the pulmonary trunk has been cut on this one, so you can't see the pulmonary arteries, but know that you have 2 pulmonary arteries leading off from the pulmonary trunk, going to the right and the left lung. Okay, then you have the aorta, and in between, holding those 2 blood vessels that are going to carry high pressure blood, is the structure known as what? It acts like a ligament. Close. The ligamentum arteriosum is going to connect the pulmonary artery to the aorta. Okay. I think that's everything on here. Okay. So remember we had three sources of blood returning to the right atrium, which is right here. We had the what was the first one we had? Right, the superior vena cava returning blood from the upper portion of the body. From the lower portion of the body, we have the IVC, right, the inferior vena cava, taking blood back to the right atrium. And see, you have to probe each opening to see where it leads. This one here has actually been severed in between, but imagine that this was still connected. So there's an opening at the superior portion, so SVC. There's an opening at the inferior portion, that's your IVC, both leading into the right atrium. Okay, your third source of deoxygenated blood return to the heart is the what?
Coronary sinus.
Right, coronary sinus. So all of the coronary veins returning from after supplying blood to the heart tissue, they're all going to converge and return into the coronary sinus, which is this structure right here. So if you go to your IVC, you can actually probe into the coronary sinus right here. See? Okay, so now we're going to look inside the heart. We have 2 AV valves leading from the atria to the ventricles. If this is which side of the heart is this right here? This is the right side of the heart. This is our left side of the heart, separated by this structure here. The interventricular septum. So inter, meaning between, ventricular, in between the ventricles, and a septum is a divide-in structure. So that's right here. So the right ventricle wall, how does it differ from the left ventricle wall?
Thickness.
Right, so think about where blood is being pumped. The right side is pumping blood to the lungs. The right side is pumping blood to the body. So the wall is thicker to generate a higher contractile force to pump blood farther. So that's how you guys will need to be able to tell when the heart is open, if it's open. Okay, so back to the valves. These structures here with the flaps and these little stringy materials, these are each your AV valves. So if we're in the right side of the heart, which AV valve are we at?
Tricuspid.
Right, tricuspid. Sometimes you can count the flaps, sometimes you can't quite. So also know that once you're above the AV valve, you're in the, which chamber? Atria. When you're below the valve, you're in the ventricle, okay? So on the left side of the heart, we have this AV valve, which will be your the mitral or the bicuspid valve. Same thing. Okay, so let's go off of these stringy things. So if the AV valves are a connection between the atria and the ventricle, we have the, what are these? The chordae tendineae, which are going to route the AV valve to the ventricles. So the extensions off of the chordae tendineae that's rooted into the ventricle, these are the papillary muscles. So it's hard to see right here, but wherever you see chordae tendineae and you have muscle attached, that's going to be papillary muscle. Okay. The other structure you have in the ventricle wall, these ridges that aren't connected to chordae tendineae, these are the, you know what these are? Right, trabeculae, which refer to ridges, trabeculae carnea, are going to be those ridges along the wall. Okay, in some hearts, depending on which ones have been dissected, you'll see a structure connecting the right ventricle wall to the interventricular sulcus, and that would be the moderator band. Right, so this really thick band right here, this is the moderator band, and it's preventing overstretching of the right ventricle. Okay, it's only in the right side, not in the left, and make sure you know why that is. Okay, so next we have, okay, let's go over the 3 layers of the heart. So the outermost layer, the shiny thin layer, is epicardium, and you can see how thin it is if you look from the inside. The myocardium, or muscle, myo means muscle, that's basically the meat of the heart, the one that's actually going to contract. And the endocardium is this other thin, shiny layer that we see on the inside of the heart, right? Okay, we found the valves. So we had papillary muscles in the ventricles. In the atria, we have a different set of muscles, or a different name for these muscles, and these are the atria. Only in the atria are the pectinate muscles. Okay. Oh, are we already there? Okay. Oh, let's go over the other valves. So we have our semilunar valves leading from ventricles to major blood vessels. So coming off from the connection between the right ventricle and the pulmonary trunk, we have the pulmonary semilunar valve. Okay, and then leading from the left ventricle to the aorta, we have the aortic semilunar valve, and this one's a little deeper inside. But just think it's going to be at the base of those blood vessels. It's the closest connection between the blood vessels and the ventricles. Okay, so those are your semilunar valves. Okay, leading from the aorta, you'll find the openings to the coronary arteries. So these you can't see as obviously, you just kind of have to probe until you feel an opening. So this is the anterior portion of your heart. Here's your aorta. If you probe posteriorly and to the right side, you should find the opening to the right coronary artery. If you do the same for the left side, you'll find the left coronary artery, or the openings to those arteries. So now we're not really going to be able to see very obvious structures, but you have to know where they should be. So from the left coronary artery, it's going to wrap around the heart and supply blood to the left side of the heart, right? So when it comes around, it's going to split into 2. The split that goes along the anterior interventricular sulcus is the LAD. LAD stands for left anterior descending artery. And so it's on the left side of the heart, on the anterior portion, and it's descending down the ventricular wall to the apex. Okay, arteries and veins normally run parallel. If the artery is taking oxygenated blood to the tissue, the vein is going to return deoxygenated blood back to the heart. So from the LAD, once blood is delivered, you have the great cardiac vein, which is going to run back. The great cardiac vein eventually empties in the coronary sinus to be returned to the right atrium. Okay, so we have left coronary artery coming around. We have it branching into the LAD. We also have another branch that's going to go around the circumference of the heart. This is your circumflex artery. And I think that is everything. Did I miss anything?